Morning. We are back at the metrology and measurement lab of SMVITM Bantakal. Now this particular setup is called an LVDT, which stands for Linear Variable Differential Transformer. This experiment is called calibration of the LVDT using a micrometer. You can see a screw gauge here. The principle of working of this LVDT is that it looks something like this from the inside. You have one primary coil and then you have two secondary coils. And what you see here as a rod is actually made of soft iron. It is called a soft iron core, which runs along the length of the cylinder inside. Ferromagnetic material. Now from high school physics or high school science, we know that if there is a ferromagnetic material which runs through a magnetic field, it is going to interrupt or interfere with the magnetic flux which is generated by these three coils. Now the movement of this soft iron core within the magnetic flux or magnetic field is going to give us a measure by which, or the distance by which it has moved inside. We are going to calibrate this particular setup. So we are going to calibrate this particular setup using a micrometer which has been pre-calibrated. Now if you look at the reading here, it is showing something which is very close to 10, and if you see the reading on this micrometer, it is actually showing, or it is actually measuring 20. Okay, so this is 20. Now the calibrated zero of this micrometer will be at the 10 centimeter mark, or 10 millimeter mark, sorry. So as you can see, as I am rotating the micrometer, the soft iron core is getting pushed into the LVDT and the reading is going to change proportionately. Now this is actually the calibrated zero of the micrometer. Right now when it is at 10, the micrometer, or not the micrometer, the LVDT display is showing 0.51. This needs to be rotated. The zero gain potentiometer needs to be rotated and made into 3, not into 3, I'm sorry, made into 0. As you can see, the value is going down, but not enough, because this instrument is very cold. It needs to be turned on for at least 15 minutes for it to warm up, just like IC engines. So this needs to warm up and then it will come down to 0. So this is actually the calibrated zero of this instrument. The way that the LVDT is going to calibrate it is that from 0 we are going to take 10 readings to the left, and is supposed to show negative readings. Then we bring it back to 10 and then again take 10 readings to the right, which is supposed to show positive readings. And then the actual distance by which the core has moved can be measured using the micrometer. And then for the actual distance measured, we are going to take the reading which is being shown here. And the difference, or the percentage error, is calculated, and that is how this LVDT is calibrated. Now if I rotate this in, you can see that the value is going to become negative. So for example, if I take it all the way to 5 on the micrometer, so right now it is at 5 on the micrometer, it is showing minus 4.95, which is very close to 5, but there is a difference of about 0.04. Now this difference is very small right now because the instrument has been on for about 5 minutes and it is slowly, gradually warming up, and the reading will come much closer to the actual reading that is shown on the micrometer. If I very slowly go to say 4 or say 3, so right now it is actually should have shown minus 6, but it is showing minus 5.99 or 0.98, which is very, very close to minus 6. Now let me go towards the positive side of the measurements. If I rotate, I'll have to go till 10 So this is the calibrated 0 position, which is again not showing 0, but it is showing about 0.23. So the error at the calibrated 0 position is much larger compared to the actual measurements. If I keep rotating, so if I go to 11 here, it should have shown 1, but it is showing 0.75 or 0.76. So if I go to 13 or say 14, this is 14, it should have shown 4, showing 3.8887. So as you can see that in this particular instrument right now, the error on the positive side is slightly bigger compared to the error on the negative side. This is not a problem because this is not being used for any measurements as such. This is an experimental setup which is for calibrating the LVDT only. So similarly, more readings are taken on the positive side, more readings are taken on the negative side, and the percentage errors are calculated. Thank you.